Welcome back to the channel. Today, we're creating a dual carriageway road in Blender using geometry nodes. The cool part is that it's fully procedural, so you can easily customize it. In the Modifier tab, you can switch between a dual or single carriageway with the roadway type option. You can also adjust things like the center gap, road width, shoulder width, and number of lanes, plus the footpath width. The traffic panel lets you turn on street lights, change pole types, and adjust lamppost spacing. In the railing panel, you can customize both inside and outside railings with various style options for each. To begin, we've created the road with lane markings. In the Geometry Node Editor, you can find the node responsible for generating the lane markings, and the node here is the one creating the road. First, adjust the curve type by using the Set Spline Type node, selecting Catmull ROM. Next, add a Resample node and set it to Evaluated. Use the Set Spline Resolution node and set it to 3 to smooth out the curve. Now the curve is smooth and ready to continue. Currently, we have one road, but we need to create two separate roads. Right-click here and link it to the view. We still only have one curve representing a single road, so the next step is to split the curve into two roads. As we discussed earlier, splitting a curve is straightforward. Let's walk through it. Start by adding a Curve to Mesh node. Then, insert a curve line node and connect it to the profile. After that, add a Combine XYZ node. Insert another Combine XYZ node and connect them together. Now add a Math node, set it to Multiply, and input -1. Connect this to the first Combine XYZ node. Add a Group Input node and link the road width value to both Combine XYZ nodes. Next, delete the geometry by adding a Delete Geometry node and setting it to Edge mode. Add a Compare node and an Edge Vertices node. Connect Vertex Index 1 to input A and Vertex Index 2 to input B. Set the comparison to Equal and enter 1. Plug the result into the selection input. Finally, add a Mesh to Curve node. Right-click and link it to the view. Now you should see two curves. Yes. Let's switch to the top view and straighten the curve in Edit mode. From here to here, we have the center gap distance. From here to here, we measure the shoulder width. From here to here is the road width. And from here to here is the shoulder width again. The red line represents the center line. Now let's calculate. The distance from here to here is the center gap divided by 2. The distance from here to here is the shoulder width. The distance from here to here is the road width divided by 2. Now we can apply this in the geometry node setup. Before proceeding, create a node group by pressing Ctrl-G. Then press N and rename it to road width. For the shoulder width and center gap, CG. Copy the group input and plug the road width into a Math node, dividing it by 2. For SW, divide it by 1, then copy the node again and plug in the CG value, dividing it by 2. Use a math node set to add to sum these values, then plug the result into both nodes. Exit the group by pressing Tab, then press N, and rename it to Center Gap. Connect the center gap to the CG and the width to the SW. Increase the center gap, and now you've created 2 roads with the center gap. Finally, rename the group to Node Curve Line 2. We encountered an issue with the lane markings. While they are correct on one road, they are misaligned on the other. Additionally, this route has a centerline marking, which is unnecessary for a dual carriageway. The first step is to remove this unnecessary marking. Once that is done, we need to fix the lane markings on the other road. To do this, we right-click on the road and link it to the view, revealing the curve numbers ranging from 0 to 9. For the sideline marking, we must select curve line numbers 0 and 4. Previously, for the separate dashed line, we had chosen curve number 0 and set the number of lanes to 4. Now, in addition to 0 and 4, we also need to select lane numbers 5 and 9. To achieve this, we copy the existing node and paste it below. Then we add a math node, plug in the number of lanes, set the value to 5, and connect it to the B input. To select curve number 5, we copy the node again, set the value to 1, and plug it into the B input. Now the lane marking issue is resolved. Before proceeding, we rename the node to Roadway, then group it using Ctrl-J and rename it Curve Line for Roadway. Next, we create the roadside curbs by copying the existing curve line node and joining it to the joint geometry node. We move it closer and rename it Curve Line for Inside Curbs. Switching to the top view, we check the curb's position. Which is determined by the center gap divided by 2, the shoulder width, the road width, and another shoulder width. Now we modify the curve line 2 node group by copying the center gap value and dividing it by 2, getting the shoulder width and dividing it by 1, retrieving the road width and dividing it by 1, and taking the shoulder width again and dividing it by 0.5. These values are then plugged into the input group for external control. The shoulder width input to SW with a default value of 1, and the road width input to RW with a default value of 2. We then sum the 3 values using a math add node and plug the result into the required inputs. Now right-clicking on the curve line for curb output in the view node, we should see 2 curves. Next, we instance the curbs along this curve using instance on points by dragging the curb asset from the asset browser, connecting it to the instance node, and resampling the curve with a length of 0.31 meters. To fix the rotation, we use align rotation to vector, connect it to curve tangent, and select the y-axis. Finally, we group the nodes together, rename the group Node Y, and rename the instancing setup to Instance Curbs using Ctrl-J. To create a footpath, we begin by setting its width to approximately 2 meters. In the input settings, we rename it footpath and set the subtype to distance before closing the input panel. We then copy the existing curve line node, paste it, and rename it curve line for the footpath. Dissolving any unnecessary parts for refinement. For the footpath, we use the curve to mesh node. A quadrilateral is added and connected to the profile input, with dimensions set to 2 meters by 0.45 meters. To keep the footpath width adjustable, we connect a group input, allowing us to plug in the footpath width parameter. Switching to the top view, we determine the curve line for the footpath, ensuring its placement is accurate. The distance is calculated using footpath width divided by 2, the road width, 2 shoulder widths, and the center gap divided by 2. We then open the node group properties by pressing N, create an input labeled FW, duplicate the value node using Shift-D, assign the footpath width, and collapse it using Ctrl-H. After dividing it by 2, we sum all the values and connect them to the group input. Renaming it FW. Exiting the node group, we link the footpath width FW to the footpath and set its value to 2. Finally, we organize the nodes using Ctrl-J, rename the group Curve to Mesh Footpath, and increase the text size for better readability. To create the outside curb, we duplicate the footpath setup and connect it to join geometry. The new node is renamed Curve to Mesh Outside Curb. Switching to the top view, we determine the outside curve position and align it with the designated reference line. group input is removed and the size is set to 0.3 meters by 0.5 meters. With all elements configured, the final view now displays the footpath. Start by creating the outside railing. Duplicate the curve with Shift-D and paste it. Press F2 and rename it to Curve Line for Outside Railing. Then, rename it to Railing 1 and join it in the Join Geometry node. Remove the previous geometry, add a curve circle, and plug it into the profile input. Set the resolution to 8 and the radius to about 20 millimeters. Next, move the curve up using the Set Position node and set the value to 0.6 meter. Duplicate this setup join this to the geometry again. Now instance railing post 1 using the Instance on Points node. Drag the railing post from the collection and plug it into the instance input. Use the Resample node with the length option set to 1.5 meters. For railing 2, duplicate the setup with Shift-D and paste it below. Connect the curve line to it and rename it Railing 2. Choose Railing Post 2 from the collection. To fix the rotation, use the Align Rotation to Vector node. Plug the curve tangent into the vector input, select the y-axis, and plug it into the rotation input. Now insert an index switch node. Plug the output of railing 1 into input 1 and the output of railing 2 into input 2. This will let you change the railing type using the index switch. Then insert a group input and connect the railing outside value to the index switch. Duplicate the setup again using Ctrl-Shift-D. Rename it Railing 3 and select Railing Post 3 from the collection asset for the instance. Plug the output into input 3 of the index switch. Duplicate once more using Ctrl-Shift-D and rename it Railing 4. Delete the Instance on Points node and one of the Curve to Mesh nodes. Replace it with a trapezoid shape and set the following values. Offset equals 0 m, top width equals 0.35 meters, bottom width equals 0.2 meters, and height equals 1 meter. Set the Z value of the Set Position node. Check the outside railing. It should be working. For the inside railing, follow the same process. Duplicate the node with Shift-D and rename it Curve Line for inside railing. In the index switch, change it to Railing Inside. Check the inside railing, and it should be fine. However, when railing type 4 is selected, the curbs and railing intersect. To fix this, delete the curbs when railing type 4 is selected. Copy the railing outside index switch and plug it in here. Then, plug the output from the curve line for outside curb into sockets 0, 1, 2, and 3, leaving socket 4 empty. This ensures that when railing outside is set to 4, the curbs are not generated. Do the same for the inside railing. Copy the railing inside index switch and plug it in. Plug the output from the curve line for inside curbs into sockets 0, 1, 2, and 3, but leave socket 4 empty. This prevents the inside curbs from being generated when railing inside is set to 4. Next, create a lamppost. Start by duplicating the inside curb node. Drag lamppost 1 from the collection and plug it into the instance input. To control the spacing of the lampposts, press N to open the input panel. Rename it Traffic Light. Add a new input called Spacing and set the subtype to Distance. Add a group input node and plug the spacing into the length. Now here you can see that one side of the lamppost is facing the correct direction, but the other side is facing the wrong direction. To fix this, I will right-click the viewer node on the node group and plug in the mesh island. Here, I can see that the lamppost on curve No, 0 is facing the right direction, but the lamppost on curve No, in 1 is facing the wrong direction. So we need to separate this curve into 2 parts and rotate the lamp on the wrong curve. To begin, let's add a separate geometry node, followed by a compare node set to equal, which we will connect to the mesh island. Next, we copy the instance nodes and paste them below, connecting the inverted output to this instance node before linking it to the join geometry node. To make the lampposts face the correct direction, we add a rotate instance node and set the Z value to 180. We then connect this lamppost to the bottom instance as well. To position the lampposts along the roadside, we need to change in node curve lean 2. From the plan view, we determine the SW as 0.5, meaning 2 times shoulder width as dividing by 0.5 is equal to multiplying by 2, and the RW as 1. Since the lampposts need to be slightly outside the road, we introduce an additional value called offset. Inside the curve line 2 node, we press N, add offset, copy this node, select offset, divide it by 1, and then add it using a math add node. After exiting the node group, we set the offset value to 0.3 meter. To control the light with a switch, we start by adding an area light from the collection asset and joining it with the lamppost. Next, we add a switch node and a group input node, which allows us to control it through the modifier. We then connect the switch to the group input and drag it into the traffic light panel. For the second lamppost, we duplicate the node using Ctrl-Shift-D, paste it below, and rename it Lamppost 2. We then select Area Light 1 and Lamppost 2 from the collection asset. An index switch node is added. Output from Lamppost 1 connected to input 1, and the output from Lamppost 2 connected to input 2. Adjusting the index value allows us to change the lamppost type. Pressing N, we add an input, rename it pole type, and set its type to integer. We then link the pole type input to the index value of the index switch node, enabling the lamppost type to be changed from the modifier. Next, we copy the setup again using Ctrl-Shift-D, rename it Lamppost 3, and select Point Light and Lamppost 3 from the collection asset. The output from Lamppost 3 is plugged into Input 3, completing the lamppost creation process and allowing us to switch between different types. For traffic signs, we start by copying the node from Lamppost 1. We drag in the No Parking sign from the collection asset, plug it in, and remove the lamppost and light. The resample node is also removed. Next, we apply a trim curve node, setting the start value to 0.5 and the end value to 0.95. For an additional traffic sign, we duplicate this setup. Drag in the 50 speed limit sign from the collection asset and plug it in. In the trim curve node, we adjust the start value to 0.1 and the end value to 0.9. As we only need signs at the start and end. To achieve this, we use an endpoint selection node and connect it to the selection input. This process, we successfully place traffic signs at designated positions along the road. To create the divider, start by copying the node of the inside Kerbs and renaming it Curve Line for the divider. Rename as Divider 1and switch to the top view to position the divider Kerbs. The distance should be the center gap divided by 2. In the node group, plug in only the center gap while disconnecting the road width, footpath, and shoulder width, setting values to 0. Next, add a curve to mesh node and connect it with join geometry. Plug in the input, then connect a quadrilateral with dimensions of 10 meters by 0.45 meters. To allow width adjustments through the modifier, add a group input and plug the center gap into the width. For divider 2, duplicate the previous node setup using Shift-D, rename it, and then drag a concrete divider from the collection asset, connecting it to the instance. And offset it by 1 meter in the node group. Delete the curve to mesh part since it's not needed for this divider. Now add an index switch node, plugging the output of divider 1 into input 1 and divider 2 into input 2. Change the index, and you should now be able to switch between divider types. Set its length to 3 meters. Press N to add an input. Rename it divider type. Press N again. Add a group input and insert the divider type into the index. Use Ctrl-H to hide unnecessary elements for a cleaner setup. For divider 3, duplicate the previous nodes, rename it, and modify the curve line for the divider by deleting the node group, Node Curve Line 2. Add a curve to mesh node, connect the input and join it with join geometry. Plug the output into input 3 of the index switch and select 3 in the modifier. Connect the curve line in the profile. For divider 4, duplicate the divider 2 nodes, rename them accordingly, and plug the output into input 4 of the index switch, selecting 4 in the modifier. In node curve line 2, set the offset to 0. Finally, you can follow my previous tutorial on roadside elements to complete a single carriageway road. Insert an index switch node after the join geometry and plug the dual road into input 2 and the output of the single road into input 1. Change the index switch, press N to add an input, rename it road type, and connect it to the index using a group input. Now, you can easily switch road types using the modifier. That concludes this roadway tutorial. I've included a practice file with assets for you to follow along. You can also learn to make more light pole types like these. Thank you, everyone, and please subscribe.